Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to learn about mesh analysis. As the name tells you, a mesh is a closed loop. In order to use this mesh analysis technique, we need to follow certain steps or rules. Step number 1 is to draw imaginary current. And if you have example on the right side here, you can put in any direction of this current, imaginary current, and you can name it with any name like I1, I2, or I3. So you have this I1, I2, and I3. And if you see here, I use a small letter because this is for DC analysis. Second, we need to identify supermesh. Supermesh is when you have a current source, whether this is independent source or dependent source, and this current source is in between two closed loop, like this. Okay, any current source in between two closed loop. And if you have like maybe a supermesh, you need to build up two equations. First is a KCL at the supermesh, and second is a KVL at the supermesh. Same as like in your nodal analysis. For our example on the right side here, maybe you can figure out where is that supermesh if it exists. So if you look at the current source here, and we have this current source is in between two closed loop. So you can draw this imaginary current, which is, or the boundary of this imaginary current, or the super mesh. So this is our super mesh. You need to include both loops. So according to this, you can build up the KCL at this super mesh. So how to build up KCL at this super mesh? You can draw back the figure. Obviously the I3 is flowing this side. This is the I3, and I2 is flowing this side. And then this is on your right side here, and this is the left side. Okay. The current value is 3 amps. So usually what I did is I choose the current with the same direction, which is I3 here, minus with the opposite direction, which is I2, equal to the current source. So the first equation should be I3 minus I2 equal to 3. Or if you're confused, you can draw like this. The current source going up, this is 3 amps, and then you have this branch, the I3 is flowing this way, and I2 is flowing this way. This is the node attached to all these currents, right? So current enter should be equal to current leaving. Then this one is equal to I3 minus, I3 equal to 3 plus I2. And these two equations should be same, right? So it's up to you. You want to use this one or the new one here. So it should be the same. Okay, next we need to build up KVL at the super mesh. So by looking at the figure on the right side here, the super mesh boundary includes these two loops, right? So maybe we can start at this 10 ohms. Since 10 ohms here shares in between two imaginary current, which is the I2 and I1, then what should you do? You need to include both. So voltage is equal to IR, right? So resistor value is 10, so we can put a 10 here into the mm, the loop we focus first, which is I2, because the boundary is at here, right? So you have I2 minus with the one that 10 ohms shares with, minus with I1. Then we have where is this 10 into I2 minus I1 is a positive, because of we follow passive sign convention, which tells you that entering current should have a plus sign. So that's why you have a 10 into I2 minus I1. And then you're going to have a 80 ohms here, and entering a passive element should have a plus, so you have a plus here, 80 into the current that flows through 80 ohms, which is this I2 current. So you just multiply by this, and then you have 5 ohms. 5 ohms, current entering a 5 ohms, which is a passive element. It should have that plus sign. So you just have a plus sign here. Then 5 into what? Into the current here. This is obvious because this current I3 is flowing through 5 ohms. So you multiply by I3 and then equal to 0. Why? Because this is already, we come back to our starting point. Okay. So that is our KVL at Supermesh. After we rearrange this, we have how many unknowns? Over here, we have the number one, we have only 2 unknowns. Our second equation, we have 3 unknowns. Mean to say we need another equation to solve for this problem. So where is that the third equation? It should be at I1 imaginary current here. Okay, I1 imaginary current here. So so the third step is to build up. So the third step is to build up KVL at other loops that exist. But please bear in mind that if you have, let's say, the last loop is attached to, maybe this is a current source. This is a 4 ohms, right? We just follow this. And then we have some 10 here and plus V1 here. So obviously, maybe let's say this is a current source and we put some value 5 amps. If you have this and yeah, you name it as I1, then this I1 should be equal to 5 amps. Okay, why? Because if you look at the current direction here, it's followed this way. Sorry, maybe I should change the color. The current direction is followed this way, which is the current 5 amps direction. So that's why you have I1 equal to 5 amps. Just bear in mind of this condition. If you have a current source at this outer loops like this, then the imaginary current straight away will take that value of your current source. But in our case, we don't have that, so we should build up KVL around this imaginary current 1. Okay, let's start from 144 volt here. Current is entering this voltage source, and we will see a negative sign. So this is 144, and will be flowing this way, which is the 4 ohms. Entering 4 ohms, we will have a plus sign, a plus 4 into I1, and then we will have the maybe if you want to use this one also can, but if you want to use the 10 here, which shares in between 2 imaginary current, then you can do so. So this is a plus sign because of the current entering passive element 10 ohms. So you have a 10 here into, because you're focusing on the I1 loops here, then you should have I1 minus with the opposite 10 ohms shares with, so you have I2 here, close bracket, and we have already finished our loops, so close it with 0. Okay, rearrange this equation and you will have the third equation. Okay, use your calculator and you can solve for value of interest. That is our the last steps. Okay, and I will leave this for you guys to check and find the solution. So let's recall what is our aim in mesh analysis. The aim is to find our imaginary loops, which is I1, I2, and I3. If the current source is situated at this side, the outer loops, then you should take the value of the current source. Do not build up any equation around that. Okay, I think that's all for this mesh analysis. Thank you. Let's say you have a condition that because I forgot to mention you about a current source in series with some element. Let's say you have some element here, and then you know that this is I3 and this is I2, and obviously we say that a current source shares in between two closed loops is a super mesh, and then you draw the boundary around this, right? And then so what happened to some element in series with the current source here? So what should you do is that you need to include that as a part of the boundary of your super mesh. And do not worry, just apply the same rules, KVL and KCL at this super mesh, and then you can solve for equation. Okay, I think that's all. The rest is the same. Okay, thank you.